Excellent. So for today's lab session, what I intend to do is pick up on the lab that we last left off on. That was our JavaScript lab, where we're implementing an object-oriented application in the platform game. Last time, we left off with implementing friction. So our physics should be done in this game. So at this point, the state of our game should have a character that can move around. And when I stop hitting the arrow keys, I should come to a standstill, right? So I'm applying friction. If I try to jump below a platform, I'll rebound off of it as such, right? If I try to move left to a platform, I'll rebound. If I try to move right to a platform, I'll rebound. And if I jump on top of a platform, I should stop. So at this point, the mechanics, the interactions between blocks and my character, my player character, should now be done. This is effectively a platformer, right? But there's no winning condition. There's no losing condition. There's no way for my character to die. There's no way for my character to progress. So it's not a very interesting game yet, but the underlining concept behind what drives a platformer is now implemented. The base component for what defines a platformer is now there. So what we're going to do for this lab session is to implement some additional tiles that could potentially kill the player, right? Like hazard tiles in the form of spikes, floor spikes and ceiling spikes, and that'll provide a losing condition. And then I also want to be able to implement some winning conditions where I can progress potentially to the next level. Let's see. Oh, and then here, let me, with that said, let me minimize this. Okay, perfect. Yeah, I don't want this crowding up my view. Excellent. Okay. So with that said, let's move on to introducing the concept of hazard tiles. So for goal 16, because I believe the last one we did was goal 15 for friction. Yep. So for goal 16, we want to be able to kill the player. So we can kill the player with one of two ways, a floor hazard or a ceiling hazard. So again, for every goal, since this is an iterative approach to designing our software system, we'll have our planning phase where we kind of decide what we're going to do. So here, in order to have hazards, we want to design the hazards in the game such that there are a special type of block. And so the difference between this block and the prior blocks, which are ones we can interact with, right? The blocks as they traditionally are, we can jump on top of them and we land on them. If we jump below them, we'll recoil off. And if we go to the left or right of them, we'll recoil off. So that's the traditional behavior of a block. A hazard block, though, if we jump on it in a particular way, it'll kill us. So they're going to be half-size blocks. So their collision detection behavior will be different from the standard block. And when we interact with them, we want to cause a game over condition to occur. So that's the general idea of how we're going to treat our hazards separately from the traditional blocks. So now that we have an idea, a notional idea of how our hazards behave, the next thing we're going to want to do is start our do phase. We're going to start applying these concepts. So again, we're building this with an object-oriented design principles. So we're going to try to use classes that already exist to implement our hazard tiles. So we're going to use inheritance to extend a block. And so we're going to create two new classes, a floor hazard and a ceiling hazard, and both those will extend from the block class. So before I do anything, let's actually, so here on step one, we're going to design the floor hazard class. And again, it's going to extend block and override the isTouching method for bottom collisions. So we'll take a look at what the source code does in just a moment, but let me go over here and actually create what we're going to call, the first thing we're going to create here is a floor hazard. So let me create a floor hazard .js file. Oh, let's make sure that's spelled correctly. Okay, floor hazard. And so the next thing I'm going to do, let's go to the source code and let's go to this new class file that I created, and let's go ahead and implement this class. So what's going on here? So I've created, let me save that. I've created a class. I'm going to call it floor hazard, and this class is going to extend the block class. So as a reminder here, let's take a look at this block class. Where's block? Here it is. So the block constructor requires an X coordinate, it requires a Y coordinate, and it requires an image. And the image has a default parameter. So if we just provide an X and Y, then the default image for the block is going to be tile-brick.png inside of our assets. And then that gets sent to the game object, right? Because a block extends a game object. So when we call the constructor of a block, it's going to take the X and Y coordinate and it's going to map it to the canvas coordinate, right? So our XY coordinate is based off of indices in an array, but since we're actually drawing in two-dimensional space, we have to have an offset of whatever the width and the height of each tile is. So our game object takes in the X coordinate multiplied by the block size and the Y coordinate multiplied by the block size, and then the width and the height, and then the pathway to the image. So with that said, our floor hazard is going to extend blocks. So when we call super inside of our constructor, is actually going to pass this data to the block constructor. And so what we're going to do here is we're going to pass in the X and the Y, the X coordinate and the Y coordinate. And then we're actually going to give it a different image pathway. So this is the third parameter. So when we give it a third parameter, it'll use this instead of the default value that we have been using, which is the tile image. Instead, we're going to use the tiles-spikes-floor.png. Okay, so we have a constructor defined. And then what we're going to do is we have an is touching and an is touching Y. Now recall, we're extending from block. So this is an example of method overriding, the same as what happens in Java. So going back to block, I have is touching Y, and is touching X. So here, is touching Y is defined by is touching is defined by invoking both is touching Y and is touching X. And recall that this is checking an overlap across the Y-axis and the X-axis, and it's determining an overlap based off another game object and an amount of overlapping that must occur before it counts as a collision. So for is touching X, it has to be, if there's 75% overlap, then that counts as a touch. Here, we're checking the overlap here. So here we have a little bit of wiggle room before it's considered a touch, whereas here it's going to check as soon as they start touching, it's going to count. So this has to do, the second parameter has to do with what effectively is our collision box. So touching Y is more stringent than touching X. This is like the tolerance level. So if there's any touching that happens on Y, we count that as a collision, whereas we leave up to 25% flexibility before we count that as a collision. And we can actually see that. Notice when I go to play the game, I can kind of overlap a little bit here. See, I'm overlapping a little bit with my character before I recoil off. And this makes it feel a little bit more tolerant when I'm playing the game, as opposed to if a single pixel touches the wall, all of a sudden I can't go anymore. Okay, so here we already have these methods in block. So what we're going to do inside of floor hazard is we're going to go, and by defining methods with the same name, we're going to actually change the behavior. So we're going to keep is touching X as it were, but we're going to change the behavior of is touching Y. And because we're changing the behavior of is touching Y, we're going to change the behavior of is touching. So how are we changing is touching Y in this case? Well, we're expecting to have a game object, in particular the player object, to be passed in to the floor hazard. And so the next thing I'm going to do is I'm going to go ahead and define a variable that I'm going to call the top half. And so what the top half is going to be is I'm going to get the Y value, the Y position of the floor hazard. And then I'm going to add to it. Now, remember, we are drawing from the top down. So to figure out where the top half is, I'm going to add to it or where it ends actually, where the top end coordinate ends, I'm going to add to it the height of a block, and I'm going to divide it by half. So again, a floor hazard isn't going to be produce a collision for the entire tile, just the top half of the tile, which means the bottom of the half of the tile is going to be clear for us to actually be able to maneuver through. So I'll find the halfway point of a block of a tile size, right? So I'm going to get the height, and I'm going to divide that by half, and I'm going to see if that is less than or equal to the bottom of a player. So I'm going to get the player's Y position, and I'm going to add to that the player's height. So this is going to allow me to check the halfway point of a hazard tile to the bottom of a player tile. And so if this were the case, I'll also go ahead and define the same thing for the bottom half. So here I will get the position of the player, and then I'll check to see if the player is less than or equal to the position of the tile plus the tile's height. So effectively what I've done is I've broken this down and computing the top half of the tile and the bottom half of the tile, and I'm going to return whether this is true, if I'm touching on the top half and the bottom half of a tile. So this allows me to know if I'm jumping on top of a floor hazard or jumping above a floor hazard. And then with my isTouching method, I'm still going to invoke isTouchingX. But then what I'm also going to do is I am then going to use the new isTouchingY method. And notice the isTouchingY method actually uses a different set of parameters. There's no tolerance level anymore, right? So it just means the player object. And so that's why I'm overriding this method, because the other one required 2 parameters, and this newer updated one only requires 1. And again, the notional idea that you want to take away here is that a hazard tile, in this instance, let me create another block. So if this is a normal block, a hazard tile in terms of collision for a ceiling hazard would only take up this amount of space in terms of collidable space. So our update to our code is checking the halfway point on a traditional tile and only determining a collision if we're touching between this point here and this point here. Now notice that doesn't affect X, right? The width of a tile is still the same for collision purposes, but now we are ignore this bottom half. So that's really what the update has done. Oh, yeah. I can zoom in on the code if that helps. Let's see here. Does that help with the readability of the code? Excellent. Okay, so now that we have our floor hazard made, the next thing we want to do is we want to do the same thing, but we're going to implement also a ceiling hazard. So the floor hazard, again, represents something that's going to be, hang on, let me go back. So here, this represents the ceiling. This would represent the floor. So actually, so let me make this floor hazard visually would look like this. And if the player touches there, then the player would die. Can I change arrange order, bring to front? Okay. So if the player touches here, that would be a collision. But if a player is here, that wouldn't be a collision. And then on a ceiling hazard, that would relationally render like here. And actually, let me do a different color, just for posterity's sake. Let's do green. Okay, so here, if a player interacts here, this would be a collision where this wouldn't be. Excellent. So now let's get our ceiling hazard. And we'll just kind of walk through that. It's actually going to be very similar to what we just did. We're just going to change the is touching on Y. So let's do a Ceilinghazard.js. Okay, so let's grab this and let's put that in there. And I will paste the new code. So Ceilinghazard is also going to extend off of the concept of a block, which means when we invoke the constructor, we're going to take in an X, Y, and coordinate. And when we go ahead and invoke the super constructor, it's actually going to invoke the constructor on our block class, the thing we're inheriting from, which requires up to 3 parameters, an X, a Y coordinate. And then we're going to send a new image path to replace the default image path. And this is going to be the tile spikes on the ceiling image. And again, we're going to redefine what it means to be touching on Y, because we need to compute the top half and the bottom half of a hazard tile as being the halfway point, starting from the midway point and going down to the bottom of a tile. I'm sorry, for a ceiling tile, it's going to be at the very top of the tile to the midway point, whereas the hazard tile was starting at the midway point and then going to the bottom. That's why in our computation for the top half on the floor hazard, we were starting with the halfway point, right? So we're getting the Y position and we're automatically adding to it halfway of the tile. So the topmost position is the halfway point, and then we were checking that towards the player's coordinates for the player tile, and then we were computing the bottom half of the tile like normal. So in relation to that, the Ceilinghazard will do the top half like normal, where it just uses the coordinate of the tile and compares it towards the bottom of the player tile. But then the bottom half is going to be a little bit different. Here, it's going to stop at the halfway point. So so we'll use the Y position, but we'll only had half of the tile's height as opposed to the full height. So notice both of these are very similar. It's just one is evaluating the top half of tile where the other is doing the bottom half. And then again, since we're redefining how touching Y works and we don't have a tolerance level anymore as a second parameter, we just have the singular parameter, we're going to redefine is touching to be the original is touching X on the parent class. That's why I'm using super here. I did the same thing on floor tile, but then I'm going to use the new method that's defined inside of this class, the override it method for is touching Y. So now whenever I call is touching on a ceiling hazard or on a floor hazard, these methods will get invoked instead. Again, these are just basic kind of polymorphic inheritance style behaviors you'd expect in an object-oriented software system, and that we can take advantage of. Okay, so now that we have a ceiling hazard and we have a floor hazard, the next step will be to go into the properties of our scene and create a new instance variable so that we can start tracking our quote unquote monsters. I could also call this hazards, but you know, I'll be consistent with the literature here. So let me go to my scene. And so at the top in my instance variables, I'm going to go ahead and add a new instance variable that will represent the things that can kill us, which I will notionally call monsters. And so now I'll go into the constructor and I will actually initialize the state of my monsters instance variable will be the next thing I do. So let me go into my constructor here. And I will set, so just like my blocks start to be an empty list, my collection of monsters will also start to be an empty list. Yeah, effectively. Well, that's a good notional view. That's why it's a good idea, or that's one motivating reason why I use the concept of monsters is, yeah, Goombas or any other kind of hazard in a platformer could think of, or any other kind of monster in a platformer could be thought of as a hazard, but one that has rules that dictate it being able to move around in the world. It can interface and kind of have its own set of physics that it applies to. So for the purpose of this lab, I restrict all of our hazards to be stationary, but it wouldn't be difficult for me to add in a new hazard that can move around. And so a Goomba might be one that just moves across X and Y. And then if it steps off a platform, it can just drop out of the stage. And then I could have other hazards that could kind of bounce around, or some that can move vertically around. And then I might put them in a different collection if it has different behaviors, for instance, or I could keep it in the same collection, but when I interact with it, it would be different. Like the result of it is touching on a Goomba is that I could jump on top and then it would actually remove that hazard from the stage, right? I wouldn't die from it. I would actually kill the hazard. But those are just additional specifications that we could add to the logic. It wouldn't be that hard for me to create a Goomba class, extend the block class, and add all those new additional concepts. Okay, now with that said, let me go back into the scene. And so I've created this instance variable to track my monsters. I created an empty list. So the next thing I need to do is when I go to set a tile from reading the map data, I need to check the cases for when I have an uppercase A or uppercase V to determine when to create a new floor hazard or a new ceiling hazard. So let me go ahead and grab these two lines here, and I'm going to go into my set tile. Let's see, set scene, set tile here. Right now, on the case of a hashtag, I'm creating a new block. On the case of an @ symbol, I'm creating a new player. Well, now I have two new tiles that I want to define, so that on the instance of A, what I'm going to do is create a new floor instance at X and Y. And I'm going to then take that instance and I'm going to push it into my monsters list. And on the instance of a V inside of my map data, I'm going to create a new ceiling hazard instance of that X and Y. And I'm going to push that into my monsters list. And again, do I have my world data? Yeah, so here would be two instances of where the ceiling hazards should go ahead and implement, and here would be two instances of where the floor hazards should implement. So we could kind of visually reference our world data to what we're about to render. Okay, so let me go back to my scene. There we go. Okay, so now I have the ability to determine when and where to go ahead and create my floor hazards and ceiling hazards. So the next thing I need to do is inside my draw method, I actually have to tell the scene to draw those hazard tiles. So let's go into the scene's draw method. And right here, I'm drawing the background image. And then I'm going to iterate for each block in my blocks. I'm going to tell that block to draw. And so underneath that, for each monster in my monsters collection, I'm going to pass this anonymous function that the monster item will invoke the monster draw method. And then I'll tell the player to draw. This should now draw my tiles, my ceiling and floor hazards. And the last thing I need to do before I can test this out is to go ahead and insert these scripts into my HTML document, because that acts kind of as my dependency manager of sorts for all of my JavaScript files. So I'm going to place these right under my block.js file because they rely on block, right? A floor hazard and a ceiling hazard, since they extend the block class, a block must exist in order for those to make sense. So in terms of ordering my scripts, it naturally feels just to go ahead and put those directly under the thing that it inherits from. So let me go to my HTML document here. And underneath block, nope, it's not that. I will now add these script tags. There we go. And at this point, I should now be able to test, right? So now we're done the implementation. I can now do an assessment, and I should now start to see ceiling hazards and floor hazards display inside of the platformer. Now, a special note here, we haven't defined collisions on our hazards yet. All we're doing is we're parsing their locations where we're storing them inside the scene, and then we're also rendering them inside of our scene. But we haven't done anything in terms of defined any interactions between the player and the hazards yet. So now if I refresh the page, there they are. But again, if I jump on them, you'll see I could just jump right on top of them, right? They don't do anything quite yet. But we can draw them. We see, and we can actually match this up with the world data. And we see that, yeah, we got the locations where they should be. Excellent. Okay, so let's move on to the next goal. So our next goal is to actually define our first condition, our game over condition, which will be the lose condition. So let's define the approach of what it means for our player to be able to lose in our platformer game. Our lose condition is when the player touches any hazard tile, then the game should end. So for each game update, in order to do this, the game should ask the scene if the player is dead or not, and the scene and sets a game over variable based on that. So the scene will iterate through each hazard and determine if the player is touching it. And if the player is touching it, then the player will be dead. Otherwise, the player is considered alive. And the game over state will be based off of whether the player is dead or not. So that's the notional concept that we're going to be doing here. And in fact, what I think I'm going to do is, let's start with our first, in order to implement this, let's start doing some things. So the first step is we're going to create a method inside of scene that's going to define whether it has collisions or not. And effectively what that method's going to do is return if a player is touching a hazard. So we're going to add this new method. Let's go to our scene class here. So we're going to go into our scene and we're going to create this new method, has collisions. And effectively what we're going to do is in our monsters collection, we're going to use this sum method. So the sum method is a higher order method, which means we pass it a method and it's going to iterate through every item inside of our monsters collection, inside of our monsters list, and pass as a parameter each item inside of it. So for each monster, it's going to invoke the monster is touching method and pass in the player character. So recall that this returns back a true false value. And what sum is going to do is if for any instance that this is true, then sum will return a true value. So you can think of it as an existential value, right? So if at least one is true, if it's true for at least one thing inside of the collection, then this will return a true or false value. Now there's an alternative to this I think I cover inside of the lecture called all, where everything would have to be true to return a truthy value. So this is almost a way of getting an or and type of logical operators defined on top of a collection of things. So very powerful method we have here. So this will allow us to, in one line, be able to iterate through and determine if our player is touching any of the monsters. Let me save that. Then the next thing I'm going to do is inside of my game's update method, I need to go ahead and set a game over value based off of whether the collision has occurred with our hazards. So what I'm going to do here is, let me go to my game. So inside of my game's update method, after I'm done updating my scene, updating the controller, I'm going to have this is over variable. So let's actually, which I already had defined here, right? Which I'm already evaluating here, right? So here, this is the first time I'm actually mutating the state of is over. We have it defined since the beginning. We initialize it to false and we've never set it again. So now we finally have an opportunity where we can set is over. And so we're going to set it each time on the game update on whether the scene has a collision or not. And again, the scene's collision is based off of iterating over all the hazards and determining if the player is ever touching one. Okay. So now at this point, since we're updating the loop control variable that we've already defined inside of our main method, we should be able to test at this point. That should be able to create the game to stop looping if at any time is over becomes true or the player is touching a hazard. So let's try to touch a hazard and see if the game stops. So I'm gonna refresh my page here. And I'm going to jump on this tile, and yep. And notice inside here, I get my game over message, right, from my console log here. That lets me know, which again was already in there, but we had never had a chance to really see, because we've never toggled that is over variable. And then let's check on a, yep. And so it works for both ceiling and floor hazards. Perfect. So now we have our lose condition, and this seems to be working correctly. So the next thing we want to do now is start to consider, well, how can we create a win condition for our game? So for our game, if you get through all the stages, just like in Mario, then you will have effectively won the game. But since this game is going to have more than one stage, we're going to have an exit tile. And the exit tile is going to be a special type of block, just like the ceiling and the floor hazards were special types of blocks that will allow the player to advance to the next stage. So they're effectively doorway blocks. So their collision detection behavior will be a little bit different than a standard block as well. We won't want to like recoil off of them, right? We won't. So when we collide with them, we don't want to bounce off of them. We want to be able to do something else. We want to progress to the new stage when we interact with an exit tile. So let's go to the do phase. So now that we kind of have an idea of what we're going to implement for this goal, we want to consider how we're actually going to do it. So we're going to create an exit class by extending the block class, and then we're going to draw the exit into the scene. So notice we're going to start the same way we did with the floor and the ceiling hazard. We're going to start by defining a class and just making it draw. Then we're going to worry about defining the interactions between a game object or player object and the new tile afterwards. But we want to do the simplest thing of just getting it to render. So let's go and create an exit tile. Excellent. And so let me get to my here and exit here. Perfect. Okay, so let's open up this new JS file, exit.js, and let's define a new class. So this new class is going to be the exit class. It's going to extend off of the block class. We're going to have a constructor for this class, which is going to take an X and Y coordinate. We're going to pass this data on to the parent constructor. And again, we're going to pass 3 parameters, the X and Y coordinate, and we're going to provide a new value to replace the default value of the 3rd parameter to be the pathway of the image for a tile exit, an exit tile. And then here, I'm going to redefine is touching with new tolerances. So recall the original tolerances for a block. Let's take a look at it. Is going to be is touching is here. So it's going to be a tolerance where there's no tolerance on Y. And there was a 25% tolerance on X. So we're going to fiddle around with that a little bit. And for an exit, we'll have the tolerance of very little overlapping, at least. Like if at least a quarter of the player is touching on both the X and the Y, then we'll consider that a touching on our exit and consider that a touch. And again, these are things that could be defined. The tolerances, your hit zones, or things you can discover and play around with while you're playtesting the game. So by all means, while you're implementing this on your own, play around with these tolerances and see how the game feels if you were to use a 0.5, a 50% tolerance, or a 0.75, a 75% requirement for overlapping, or even a 1.0 where you needed 100% overlapping before it considered you touching the exit. Okay. So now that we've defined our class, let's go ahead and we have to go into our scene and create a new instance variable to hold a reference of that exit tile. And there's only going to be one exit per scene. That's going to be a rule we're going to set. So each scene has one exit, whereas it could have multiple blocks and multiple monsters, but it can only have one player. So now let's go into the constructor. I guess we don't have to go into the constructor because we actually go into the helper method of set tile, because we don't have to initialize. Since there's only one exit, we don't have to create a list. So we'll just go to the set tile here, and we're going to create the new condition. So on the instance of an exclamation mark here, we're going to go ahead and just create a new instance. We'll instantiate an instance of exit at that X and Y, and then we'll just store that inside that instance variable of this.exit, similar to what we do with player. Okay, so that allows us to actually go ahead and set the tile. So the last thing we'll really have to do inside of our code is to go ahead and inside of the scene's draw method, tell the exit to draw. Otherwise, we won't see it. So what we'll do is we'll draw the exit right before we draw the player. So the draw ordering is going to be draw the background, then draw all the blocks, then draw all the monsters, then draw the exit, and then draw the player. And then once we do that, well, we've created a new class. So we have to go ahead and add that into our HTML document. Since the exit is a special type of block, we will add it into our HTML after the block class so that we know that it exists. So let me find my HTML here. Here it is, platformer. So I'm going to go right under Ceilinghazard, right? And we will add our exit.js there, so that we know that block exists before exit. Okay, and once we've done that, well, that should at least render an exit tile for us. So again, we don't have collisions for the exit, so we don't have any defined behaviors, but we should at least see it now. So if I refresh my game, I now have an exit. So let's see if I can get to the exit. So there's a special thing I can do here where if I run off of an edge, but I don't use my jump, I can do a mid-air jump. That's kind of one of the novelty features in this game, just like that. And then we'll jump up here. Here, you see, I'm on the same location as the exit, but it's not doing anything because I haven't implemented that, but I can see it. So that's perfect. And since the draw ordering is I draw the exit into the player, I appear to draw on top of it. Excellent. So now the next thing I want to do is, well, I want to create a game over win condition. So I already have my loss condition. So let's talk about an approach for how we might define a win condition for this goal. We might define a win condition as when a player touches the exit tile to advance to the next scene. And if the player is on the last level, if there's no levels to advance to, then that should be our win condition. And we've won the game. We've beaten all the levels. So in terms of applying this concept, the way we might want to approach this is we want to check if the player is touching the exit during each update. And if the player is touching the exit, then we want to increment a level variable that for our game to load to the next scene effectively and check to see if it's the last level. So before we load to the next level, we want to check what the level is. If it's the last level, then it's a game over, right? But if it isn't the last level, then we would update the scene to that level by getting the level map from the world class and constructing a new scene in the game. And then we would register our player object to the controller of the new scene that we've loaded in. So we have to define two different instances. Each time we touch the exit, we have to determine if it's the last level. If it is, that's easy. We just set game over to true and we've won the game. But if it isn't, then we increment level and then we'll load the next level. So let's see how we can actually do that step by step. So the first thing we're going to do is we're going to go into scene and define a Git Exit method. And that's just going to provide access to the scene's exit from other classes. Because remember, all of these instance variables are private, so that each class is responsible for maintaining its own state. So inside a scene, I'm going to create a getter that's going to allow me to get the exit. Okay, so now that I've done that, what I want to do is I want to go into my world class and create a get length method. And what that's going to do is provide access to the world's levels array length from any class. So again, this is data that's going to be needed external from the class. So now I'm going to create a getter method. So let's go to world. And here I'm going to get length. And all I'm going to do, this is going to act almost using like the kind of a wrapper method where I will ask levels what its length is and just return that value so that we can know how many levels exist inside of our world. Then our third step is we're going to define inside of our game scene, inside of our game class, a load scene method. And what this method's going to do is it's going to load a new scene within the game and bind our player instance to a new controller. So every time we load a new scene, we're going to want to create a new controller for that player, because we're generating a new player each time. We're not reusing the player between scenes. And if you wanted to do that, then you'd have to modify the logic of this game slightly to be able to use the same player across levels. But as it were now, we're essentially removing the previous player instance and replacing it with this newer one that we construct for each scene. So let me go into my game here, class, and I'm going to create a load scene method. And so what load scene is going to do is I'm going to make a call to my world instance to get a level. So again, what this does, the get level, is giving a number, right, which is an integer value. I'm going to index into the levels collection, and that's going to return, let's see what is inside of our, let's go back to world data. So recall that our world data, it has index, so 0, 1, and 2 in this example, and it's essentially a string here. But when it gets parsed, it's a 2D array. It's a 2D where we can give indexes in. So if we use level 0, we get this. If we use level 1, we would get this level, and if we use level an indexer of 2, we would get this level. So let's go back to game here. Okay, so we're going to get the level data, and that will represent a map. And then I will pass that map to the scene, and we're going to create a new scene instance. And so remember, the scene constructor will parse the level data that we give to it and build the new scene with all of the blocks, with all of the exit tiles, or the one exit, with the player tile, and with all of the monsters along with the background image. And so now we will overwrite the old scene with this new scene instance, and then we'll create a new controller instance, and we'll pass to the controller the player instance from this new scene, and then we'll overwrite the old controller with this new controller instance. So when we load a scene, we're changing the value of scene and controller instances to be reflective of this new scene. And now the next thing we're going to do is inside the update method, we have to do some evaluations. So let me go ahead and grab this, and we will step through this code. Okay, so inside of our game here, let's see, inside of our update method, perfect. So inside of our update, we're going to do the following. We're going to check if the scene's exit is touching the player. So we're going to check to see if the player is touching the exit from the scene. Then we will increment our level instance variable. So it starts at 0. So it would increment to 1 if we're on the starting scene. And then we're going to check inside of this if statement. We will, after we increment the level, we'll check if the level is still less than the number of levels in the world, so the length of the world's collection, then we will invoke that load scene method that we just defined. So we'll overwrite the scene instance variable and the controller instance variable with the new data. Otherwise, we will set is over to true, because that means that the level is the same as the number of levels that we had. So there's no more levels to load. So we had won the game. And here, what I'm going to do is, let's remove this, save that. Okay, so that's the logic. We don't need that other if check. We'll talk about what that other if check does in just a moment. So let's save that. So yeah, so we're just going to check if the player's touching the exit. We have 1 of 2 choices. We'll increment the level, if the level is less than the length of the world, we'll load to the next scene. Otherwise, we'll set the game over to true. Let's test that. Refresh. And let's see if I can get to, oh, no. Let's see if I can beat this. Oh, man. Okay. I did. Notice as soon as I touched the exit, it then loaded to the new scene, level 2. Let's see if I can beat level 2. Okay, when I touch that, it loads to the third scene, and this is the final scene. Since this is the last level, when I touch that one, it now says game over. I've won the game. Perfect. Perfect, perfect, perfect. Now, suppose that I want to make my game feel a little bit more modern. Suppose I want to make it like a Super Meat Boy or whatnot. Is that the... Yeah, the last system. Suppose I don't want the game just to freeze up when I die, right? I want to, let's say, respawn the player or respawn the level, restart a level whenever the player dies. That makes the game feel a little bit more modern. Instead of doing this condition here, where I just say, hey, is over is set whenever there's a collision, I could do something else. Now that I have the ability to reload a scene, I can update the loose condition such as this. If the scene has collisions, then I can also load the scene, but since I haven't incremented the scene, it'll reload to the current scene. So it'll restart me in the position and it'll respawn instead of just freezing my game. So now if I refresh, I can, whenever I die, I just restart instead of just having the game freeze. And so now the only real condition to get to a game over state is to win the game. And if I die, then I just have to start over at that level. You see, and I'm on level 2, but each time I die, I'll instantly restart. And that makes the game a little less frustrating. Oh no. There we go. There we go. Okay, excellent. So now we have winning conditions. We have losing conditions. We can advance to new levels. The last thing we want to do inside of this platformer is suppose we want to make it look a little bit more modern and have sprite animations. So inside of my art here, let's go to the assets so we can take a look at this. We actually have more than just this one figure. We actually have 2 frames that represent walking forward. We have 2 frames that represent moving to the left and 2 frames that represent moving to the right. So let's see if we can't think of a way that we can make our character look like it's moving around inside of the world instead of just a static thing that slides. So we're going to talk about sprite animation. So for the general approach here, we want to design an approach that can animate the player by switching the image in a certain order after a certain duration. Then we will organize all of the animated poses in a way that we can easily access them. So in order to do this, we'll create an animation class that manages the collection of images for an animation, which is the current image that we're using, and how to switch to the next image to be the next current one. We'll actually use a pose enumerated type. Well, kind of. We'll actually probably use a class for that to define all the character animations. And the player will have a current pose, which is updated whenever the player moves left or right, and we'll override the draw method in player to update the image before drawing it. So we'll make a decision on what image we want effectively the game object to draw. Okay, so let's start this. It's like fire. Oh yeah, I guess that's true. And actually, this would be the process that you would typically consider for any animated sprite. So right now, we're just going to try to figure out, well, how can we cause animation to occur in between our game update steps? So recall that our game update is firing off like every like 60 times a second. So we can take advantage of that. We can change what image we're going to use for the player at any time during the game update phase. And if we update the image we use, then when the game draws, it'll use a different image and it'll give you the impression of animating. So let's define. So the first step is, well, let's create a class where its responsibility is to manage the animation. And by managing the animation, what we're modeling here is a sequence, the animation sequence, and determine which frame we're currently on in the sequence. That's essentially the role that our animation class is going to serve. So let's create. And again, the reason why I added this in there was to illustrate all the other game objects we had were like these physical concepts. But recall, in an object-oriented system, we can have classes that represent other roles or responsibilities that aren't necessarily a visual thing or like a physical component in our game world. It can help manage the rules for a process, such as determining the animation rates. Okay, so let's go back to my source code. Here we go, scripts. Okay, so I just created an animation class. Let's open up my IDE and open this up. And inside of here, let's define the class. So let's actually step through what's happening here, because this is a relatively big class at this point. As I get further along, I stop doing the smaller steps because at this point, you should understand what's happening in a lot of this code, but I'll step through it the same. We're defining a new class that we'll call animation. We're going to open and close scope here to here. Our class has a couple of animation properties. So these are instance variables. We're going to have a start time. We're going to have an index into which frame we're currently on, and then we'll have a sequence, which will be a list of frames. And so when we define our constructor to initialize these three properties for any animation, our constructor is going to require images. So for our start time, just like what Java has, we can go ahead and do date.now. So what is date.now? Let's take a look. Let's play around with this. So date is, notice date is something that's built in to the API. So I can invoke on date. It's an object. And if I do now, this is a method that's going to return the number of milliseconds that have occurred since like January 1st of 1970, which means that this is a number that is always increasing, right? So between these two successive calls, you can see that there's a difference in time between here to here. And if I do it again, it will be, in fact, you could see each time it tries to go and display, it increases a little bit more. So I can use this as a measure of time, as a timestamp of sorts. Okay, so I'm going to go ahead and get my start time here. And then the index frame, the frame index, I'm going to start at 0. So I'm going to start with the first image inside of my collection of images. And then the next thing I'm going to do is I'm going to go ahead and define my sequence. And so what I'm going to do on my sequence is images is going to be an array of images. It's going to be a collection of images and what an image is effectively going to be is just a set of file pathways, right? So images in this case would be, let me go back to my assets. So it might be like link down PNG, link down to PNG, or it might be link left to. This would be the collection of images that make up one animation. So what I'm going to do is I'm going to map across this collection of images. And for each image in my collection, I'm going to merge two objects together. So object.assign allows me to take and merge into the leftmost JavaScript object whatever is on the rightmost object. So here I have an anonymous object, just an empty object that has the key of source, SRC. So remember, every source needs to have, every image needs to have a source property, and the source property is the pathway, the file pathway for that image. So the leftmost object is going to be a new image instance, and I'm going to merge into it a object that has a source property that will be this path. So let's actually see what this does. Actually, let's again, at any time, if you have code that's confusing, you can play around with it. That's what I love about the interpreter here. So imagine that I had a object that I'll call foo. No, foo. Don't auto stop that. Okay. So suppose foo has a property, or let's say an a property that's hello. And suppose that we have a bar property here that is going to be b, and we will call this just, I don't know, 10. Okay. So now I have an a and a b. If I go to the object class and use the assign method, I can take foo and bar, two objects, and it merges them together, right? So now I have this new object that has an a and a b property. And actually, the merge saves the new, this assign saves the new property into the foo, right? So notice foo is actually mutated. What was originally a object that just had a key of a and a value of hello, after this assignment, it now has also this b property of 10. And again, bar is unaffected with this. Okay, let me clear this. Okay, so what would happen if I do this with an image? Well, let's take a look. So imagine if I had for foo a new image here, okay? And for bar, suppose I had that object that had a source property that had an image pathway. Let's say it's assets / like link.png. Okay, so when I do object.assign and I assign the image, right, that I'm creating here with the object that has a source property, then suddenly I'm creating an image that has a source tag and that. And notice, as soon as I did that, it actually looked for this link.png, and that didn't exist. I didn't use an appropriate name, but notice my browser tried to fetch it. It tried to create this image element. So that's what's happening there. So that's what's happening inside of here. So for each image in my sequence, I'm going to create a new image element, and I'm going to merge into it as its source the file path. And then I'm going to save that collection of images, image elements now as my sequence. So now I can start using those to render with. Okay, so after I constructed an instance of animation, I'm going to have a get image method. What the get image method is going to do is it's going to save as a local constant the current index. So I'm going to grab the frame index and use that as index. And again, I'm just doing that so I can use index as opposed to this big long dereferencer here. Then I'm going to grab the now time. So remember, every time I call date.now, it's constantly increasing. So I'm going to grab that time, and then I'm going to check the difference between the now time and the start time. So if the difference between the now time and the start time, which when I originally created this animation is greater than 75, so this is in milliseconds. So if it's greater than 75 milliseconds, then I'm going to do the following. I'm going to increment the index by 1. But I'm also going to take the modulus based off of the length of my sequence. So if my index exceeds the number of images I have, then I'm going to roll back over to 0. And I'm going to overwrite my frame index with that new value. So I'll go 0, 1, 2. And let's say I have 4 images. Then I would go 0, 1, 2, 3. And then 4 modulus 4 would go back to 0. So I would go 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Now for this game, we only ever have 2 frames. So it would go 0, 1, 0, 1, 0, 1, 0, 1 for my frame index. So again, this is the frame I'm currently on. And then I'm going to override. I'm going to overwrite my start time with the new now time so that I pause and wait for 75 milliseconds to overlap before I change out to the next image. So again, this is a logic that's managing what image I should currently be using to draw. And then after making this selection here, I will then return from my sequence of image HTML images, whatever index I'm currently on. Okay, so now that we've implemented an animation class, let's go ahead and define a pose class that will then use the animation to create all of the particular animations that I have for moving left or right. So the pose class will model the player's animated poses. So the animation class can manage any animation. So if I wanted to create like floor animations where the spikes are moving up and down, I could do that. Or if the Ceilinghazards are moving up and down, I could do that, as well as the player motions. So this is the more general approach, but the pose will actually define our actual collection of animations that are the poses that the player can have. So we'll actually start using that. So let's create a pose.js file. So again, this will use, I guess, the composition approach of reusing classes inside of other classes. But we've been using that this entire time. So here we have a pose class. Inside the pose class, notice we're actually going to have 2 static properties. So these are not instance variables. Notice we are not using the keyword this. We are not using hashtags because these are designed to be public as well. So because these are designed to be effectively immutable, I'm going to use all uppercase letters, similar to what I do in Java. And so since these are properties of the class itself, since they're static, I can instantiate them outside of a constructor. But notice they are themselves holding references to instances of the class. So this is defined very much as a enumerated data type is in Java. This is the paradigm we're using. So we have 2 enumerated data types, pose.right and pose.left. And pose.right will have an instance of pose that has a 2 different images, link right and link right to. So those are going to be the 2 image assets we're going to have for our right pose. And for our left pose, we're going to create a new pose that's going to use 2 different images, a left link and a right link. So notice we're having a parameter list of our images, but notice we're doing this as a set of values, right? I'm passing 2 parameters for each of these. In order for my constructor to have a variable length parameters, we can do this the same way we do this in Java. We can have a parameter that's prefaced with ... And so ... allows me to effectively pass multiple things, multiple values, and it will combine them together and store them in a list. Again, Java does the same thing. And it should have been covered in Java 1. And so the big thing about the variable length parameters, it has to be, you can only have 1 per method, and it has to be the last parameter inside of your parameter list, because everything thereafter will be combined into that parameter. So what images is effectively going to be is an array, but instead of having to define things inside of a curly, instead of defining things inside of square brackets, I can just label them as a collection here, and it will do the list definition for me. So what's great about that is then I can take this images array and pass this to my animation class. It's going to create an animation instance, and it will go ahead and define that as my animation variable. And then whenever I go and get an image from a pose, I just go and effectively I'm using the adapter design strategy here, where I will use my inner animation reference, and I will ask it to get the image. And remember, that does the logic on based off of what time it is, which of the images to return back to me. Excellent. So now that I have my pose class made, I can go and update my game object really quick, where I'm going to have to be able to get a reference to be able to set an image inside of my game object. Up to this point, I hadn't had to mutate the images, but keep in mind that it's the game object that's responsible for maintaining the image. So now that I want to animate the player, I need to change that image over time. So I'm going to create a setter method that allows me to take an image element and set the image property inside of the game object. Okay, so now that I can do that, let me go into my player and add some a new instance variable into my player. So now my player at any time is going to have a current pose. Let me find my player class here. So inside of my properties, I will now have a new instance variable that represents my current pose. And then inside my constructor, I need to actually set that current pose. So let's go into my constructor here. So what I'm going to do is I'm going to access the pose class. Now, when the pose class is originally created, I want you to see something. Let me cover this. When the pose class is first read in, notice it's actually creating these instances. So when JavaScript parses this class, I'm instantiating these instances when this code is loaded into the JavaScript runtime environment. So right and left now exists from the get-go. I don't have to instantiate anything. It starts pre-instantiated with these poses. So inside of player, I can request from pose the right animation effectively, or collect sequence, the animation instance, and I'm going to set that to my current pose. And then I'm going to tell the parent class, the game object, to invoke that set image method that we just made, and I'm going to replace the image that was provided with the image that gets returned from my current pose. So that's going to update my image as my starting image. And then when I go to move left, each time I move left, I also want to tell my current pose to use the left pose, the left animation sequence. And each time I move right, I want to replace my current pose with the animation sequence that uses the right-facing images. And then in my draw method, I'm going to update my draw method inside my player. Oh, I don't have one because I've been relying on GameObject. So I'm going to overwrite my draw method. So before I was relying on the GameObject draw method, but now I'm actually going to define one myself. What I'm going to do is I'm going to tell the GameObject to set a new image, which is going to be whatever the current poses get images. And remember, based off of time, that's going to oscillate between index 0, index 1, index 0, index 1, index 0, index 1. So this is actually, for each iteration of my draw method, going to change over time. I'm going to replace the image in my underlining game object, and then I'm going to invoke the GameObject draw method. And so once I do that, I have defined two new classes in this iteration. So let's go ahead and add that to my HTML document here. And I will, I think I could probably do that here. I'm going to do it under GameObject, but I don't think it matters. I don't think GameObject and animation rely on anything, so I could put it anywhere in the sequence, above at least. I think the thing that requires it is player. So as long as it's above player, I should be fine, because the player needs a reference to animation and pose to be able to build itself. So as long as I put it above player, I should be okay. Okay, with that said, let's see if when I refresh, if I have up, and there you go. You see, I have my player now with this new adjusted logic. It keeps replacing the image based off of time with the left. Since I start facing right, it's right. That's index 0, index 1, index 0, index 1. Now, when I hit left, it's going to replace it with the left pose, which is the leftmost images, and it's going to oscillate image left. Index 0, index 1, index 0, index 1, index 0. And it's going to keep changing it based off of the response to when I move left or move right. And so here I'm going to get something that looks like an animated sprite. I mean, it is an animated sprite that gives me a lot more, it gives a lot more polish to the game, having it be animated. Okay, and then there we go, and then we beat the game. And that's it. I think that's our last step. We've implemented, I think, a pretty full-featured application, a multi-level platformer game that has floor hazards and ceiling hazards, that has exit tiles, that allows us to advance, that allows us to win at the end, and that even animates the sprite. Excellent. So, is there any questions? We are now done with this lab. So we used JavaScript in a very deep way. We learned how to use all of the kind of JavaScript basics, the JavaScript data structures, and object-oriented definitions inside of JavaScript. So at this point, everyone should be primed and prepared to be able to do homework, the next homework, which is going to be the JavaScript homework. And so I'll leave it to you whether you want to use Canvas or whether you want to go ahead and use Phaser. I can produce a lab if you want to use Phaser. Phaser is a cool free 2D JavaScript game engine that allows you to do that does all the background game management stuff that we're doing on its own. Or you could build any kind of JavaScript object. You don't have to build the game if you don't want to. But now you should know enough about JavaScript to start working on the next assignment. Is there any questions about what we did today?
That sounds great.
Excellent. Well, I will end the recording here, and we will end the lecture, and we will talk about what to do. Oh, where's this? I keep forgetting. I might just have to. There. That's what I'm looking for. Stop. There we go. I will stop the recording.